There's a strange and mysterious place at the edge of our planet, which most of us will never see. 1.5 times the size of the USA, it holds just ice. But now, one of Antarctica's greatest glaciers has begun to race into the ocean, losing more ice into the sea than any other in the world. No one knows what the consequences for the world's oceans will be. Only one thing is certain. If we want answers, then this is the place to look.
Monkeys out there.
You'd think after 6 trips to this icy continent I'd be used to the cold. But it's impossible to grow complacent about any aspect of Antarctica. For 20 years I've been reporting on how it's changed.
It's hard to imagine that the climate could be changing here. The seas around the Antarctic Peninsula have changed almost beyond all recognition. Climate change is also having a dramatic effect.
Now I'm talking to scientists both here and in the UK about something they're reporting as a major global concern. The oddly named Pine Island Glacier is in fact one of the world's largest rivers of ice, and it's almost doubled its speed in the past 30 years. Its behaviour has left scientists confused and concerned.
The ice here is melting faster than just about anyone thought possible. It's starting to look like the greatest vanishing act on Earth. And up here, we've got front row seats.
The story starts here, on the Antarctic Peninsula. Until the 1800s, Antarctica was nothing more than a myth. And even when we discovered it was real, it retained mythic status. We thought of it as the last great wilderness, untouched, unchanging. We were wrong. Hugh Core is an aerogeophysicist. Back in 1997, he was working on a vast expanse of floating ice called the Larsen B. It was displaying worrying signs of collapse.
Each ice shelf is quite different in character, but it does seem that because of the large rifts that are opening on the ice front of Larsen B, that it's likely it could go.
About 14 years ago, you and I were sitting in a small boat just off the Antarctic Peninsula when you predicted that the Larsen B would be the next to go. How did you know?
Well, with hindsight, I should have been more forceful because we had flown over trying to gather information. There was 3 of us on the plane, and I remember you could see the enormous rifts and the way it was open. And after the flight, we were chatting, and we all felt a bit melancholy because you knew it was going to go at some point. You could see its number was up.
Hugh was right.
So that's it. That's the place where the Larsen B ought to begin. Instead, it's a place where ice meets water, and the Larsen B is vanished, it's gone. It's a really extraordinary sight.
At the beginning of 2002, it was there plain to see in the satellite images. Then, in March, there was a week of heavy cloud, and when it cleared, the Larsen B had vanished. shattered into thousands of tiny shards which would eventually float out to sea.
Scientists stared at their computer monitors in astonishment.
We knew that other ice shelves, one to the north of it, had disintegrated as well, but it went in a piecemeal type of fashion. Bits would fall off, and then more and more bits. But this one was very different. The whole ice shelf just fell apart. It literally just disintegrated.
And complete shock.
It was, yes. It was not expected. There was no prediction that said it would go that way.
As soon as the weather permitted, scientists returned to the peninsula to try and work out why it had collapsed. It didn't take them long. Tamsin Gray is a meteorologist who tracks climate on the peninsula. She's watching as the climate behaves in an extraordinary way.
So this is your weather station. Can you give me an overview of what's happening to temperatures here on the peninsula?
Well, the Antarctic Peninsula is one of the fastest warming places on the planet. Temperatures here have risen by about 3 degrees in the past 50 years, which is about 10 times the average global rate of warming.
Warming air, scientists concluded, was responsible for the Larsen B's demise. Climate change had claimed its first high-profile Antarctic victim. After the collapse of the Larsen B, attention focused in on the ice and the people who work on it. David Vaughan is a world-leading glaciologist who remembers that time well.
For a glaciologist, it was the biggest thing we've seen for many decades, an ice shelf that we thought was a permanent feature of the Antarctic suddenly collapsing in quite a short period was an enormous event for us.
This is Ice HQ, the main research station of the British Antarctic Survey, the UK's scientific eyes and ears down south. Scientists and support staff stay down here for stretches of up to 18 months at a time. One of their aims is to track every move the ice makes. Some people, however, take a little persuading, like climate scientist Liz Thomas.
I studied oceanography and I really wanted to go and work in the tropics, somewhere warm. And somewhere along the line I ended up getting diverted to the polar regions. But it's a pretty amazing place to work.
It's the kind of office most people can only dream about.
Well, wow, that's just incredible.
And one which, as all glaciologists know, is always on the move.
The glacier isn't a stationary thing. It's constantly moving towards the sea. And this really sort of shows you that, because we're in one of those fractures. So it's opened up as it's been moving. And you can actually walk around in here and see it really is moving.
Looking around, we've got a great tangle of huge icicles in here, which go in all sorts of different directions. My mind says they should all go the same way. Why are they right angles here and diagonals there?
For these larger ones, I mean, they've been forming over many years. And actually what's happening is they're dripping down in a sort of vertical, but the ice itself is moving, and it will then move with it.
And when it's a very quiet day, you can hear the sort of very deep cracks and groans. I mean, that really is sort of another one of the senses that says, OK, this is really moving, and it's moving quite fast.
Movement is one of the basic principles of ice. As snow falls across the continent, it's slowly compressed into giant frozen rivers. Gravity and fresh snowfall force these glaciers to flow down towards the sea. There, they edge out in vast floating platforms called ice shelves, whose tips break off into icebergs and float away to sea. Until the dramatic collapse of the Larsen B, scientists thought of this process happening slowly, ice moving on the timescale of centuries. So when the Larsen B suddenly disintegrated, they could only guess at what would happen next. Scientists had a theory that an ice shelf is like a cork in a bottle, holding back these glaciers. So the theory went, take away the ice shelf, you take away the cork, and the glacier just pours into the sea. It was a theory hotly contested in the scientific world. Then the Larsen B collapsed, and it meant one of the biggest questions in glaciology was about to be answered. What happens when a glacier loses an ice shelf?
Nature settled the argument. We now know that it does actually restrain the glaciers behind it. So if you take away that restraint of the ice shelf, then the glacier that's flowing into it will speed up.
The glaciers that fed Larsen B before it collapsed began to accelerate as the ice shelf was removed. It was like pulling a cork out of the bottle. The ice shelf stabilised those glaciers and slowed them down. And when the ice shelf was gone, the glaciers sped up. And in fact, they're still retreating at this moment.
An ice shelf floats, so its collapse has no effect on sea levels. But the glaciers behind it do. In just 6 months, the glaciers feeding the Larsen B dropped in height by as much as 1.5 times the height of these kites. Remove an ice shelf, scientists learnt, and the glaciers behind it raced to the seas. Ice could be swift and volatile. And it made them fear for what could happen should the rising temperatures spread. The Antarctic Peninsula is a vast formation of ice, but it's dwarfed by the West Antarctic ice sheet further south. Here, the air isn't warming nearly as fast, so scientists thought the ice shelves were safe, at least for now. Then something happened which made them change their minds. 800 miles from the nearest British base, the Pine Island Glacier has been tracked by satellite since the 1990s, and it's acting up, flowing faster and thinning.
Pine Island Glacier is one of the largest ice streams on the planet. It's a large river of ice that drains the West Antarctic ice sheet, and it's changing very quickly.
Its ice shelf was melting more than 100 times faster than they had expected. Scientists didn't know why, or how to get there to find out. Less than 1,000th of 1% of the world's population has ever made it to Antarctica. Today, science here still pushes the limits of polar exploration. To get to the Pine Island ice shelf from the nearest base, scientists have to cross 800 miles of the most inhospitable terrain on Earth. It's a place so remote that more people have landed on the moon.
Conditions at Pine Island are so tough that only one scientist has ever walked on the floating forward edge of the glacier. And he was an American from NASA, the American Space Agency. The pilot was so nervous that they stayed just 20 minutes, and no one's been back there since.
No one, that is, except a very special robot.
In January 2009, scientists sent a small remote-controlled submarine into a place no man or machine had ever been before. In icy waters off the West Antarctic ice sheet, its job was to collect data from below the Pine Island Glacier.
Adrian Jenkins is the oceanographer who was in charge.
Adrian, this is a model of the sub. In real life, how big is it?
It's about 7 metres long and just under 1 metre in diameter.
This is a really sophisticated piece of technology, isn't it?
Yeah.
You must have been incredibly excited to get your hands on it.
Oh, yeah, it's amazing. It's a tool which gives us an unprecedented view on the world beneath the ice shelves. There's no other way we can get the kind of view that the sub gave us.
Frozen sea ice normally covers the bay, but a lucky break in the weather meant that Adrian and the ship got within 3 miles of the ice shelf.
So we launched the sub into almost mirror calm water on the first mission and sent it away, very tense, knowing that this was the big moment. We were actually the first mission beneath the glacier. We had no idea what was going to come back.
When Adrian and his team saw the data, they were astonished. They thought the ice on the underside of the Pine Island Glacier was anchored to a ridge near the mouth of the bay, but the autosub had made its way 30 kilometres inland. The glacier had come unstuck, and it was floating. It wasn't warming air that was causing it to melt. It was warming seas, not just lapping against the ice, but eating away at its underbelly.
Was this a game changer?
Yes, completely. It changed totally the way we think about the system. It was just a jaw-dropper when we saw that warm water there.
What the submarine revealed that day was the latest piece of evidence suggesting that the melting of the Pine Island Glacier and the West Antarctic ice sheet of which it's a part may well be the largest source of global sea level rise this century.
In 2007, governments commissioned a report written by scientists which estimated future sea level rise around the world. By 2100, these seas were unlikely to rise by more than 59 centimetres, they said. But they also admitted that not enough was known to fully include the ice in West Antarctica. And I think that what's happening now makes that report obsolete.
Hi, David Vaughan here. Yeah, I've just been looking at those figures.
David Vaughan will be a lead author of the next 2014 IPCC report.
All the projections of sea level rise, all projections of climate change are out of date as soon as they're published. We're working in the IPCC at the moment to begin the process of doing that complete and consolidated estimate. So I'm not going to prejudge the outcome of that, but everything I think we've seen coming out of the science suggests that the Antarctic could contribute more than was known at the time the last report was written.
The world's oceans could rise 30 centimetres should the threatened part of Pine Island go. But great coastal cities could be swamped by 5 metres of water if the West Antarctic ice sheet follows it.
Certainly the events that we've seen in Pine Island Glacier make us a little bit more concerned than we were even 5 or 10 years ago, that more than a metre of sea level rise is potentially with us by 2100, certainly by 2150.
It seems increasingly likely that the future of these coastal cities will be shaped by a piece of ice at the end of the Earth. It's a future which scientists are currently struggling to bring into clearer relief. Ed King is one of only a handful of scientists who've made it to the glacier itself, accompanied only by an assistant and our camera.
We had all sorts of issues to do with getting cross-country into Pine Island Glacier from another glacier we've been studying. Should have taken 3 days. It took us 11. The weather clamped in on us. We sat in the tent for 7 days straight with 40-knot winds blowing past, complete blizzard conditions. Things broke, and by the time we finally got to Pine Island Glacier, there was quite a lot of fixing to do.
Despite the extreme conditions, Ed's managed to map the glacier bed using radio waves.
The image of the bed that we've created using this radar survey is the most detailed image of this glacier ever created. And we can see straight away from that there's melt going on down there. There's water being produced and ice melting right under our feet at the moment.
These pioneering results are Ed's swan song. After 17 tough seasons out on the ice, he's decided this is his final trip.
This is an extraordinary place. It's been a fantastic privilege to be able to work here. Sometimes you've got to recognise that time has come for something to end. This is that time. So it'll be farewell to this sort of situation in the Antarctic. It does feel quite hard.
For generations, scientists have suffered out on the ice trying to unlock its secrets. Now, technology is lending a hand. This is the wonderful world of aerogeophysics, where nothing can remain hidden for long.
So we got 4 of these utility aircraft. They're our workhorse for the Antarctic survey. But this one is special in that it's been equipped in order to do airborne geophysics. So there's cables down the wings, out to the magnetic pods and the antennas.
It's hoped that by scanning Pine Island, this plane will show what's happening deep inside the ice.
Where do you take it from here?
Well, once we get the equipment all installed, we do our test flight, our shakedown flight, and if all goes well, off we go to Pine Island. And the idea is to survey the ice shelf, the plug that's holding back Pine Island. Pine Island could answer the trillion-dollar question about sea level rise coming from the West Antarctic ice sheet.
You're really excited about this, aren't you?
Excited and very worried that we do a good job, yes.
But it's a challenge, huge challenge.
Huge challenge that we've got everything right, because it's a one-shot chance. We've only a limited time, a limited weather window, and we must get it right.
I've been coming here as a TV correspondent since the mid-1990s. It's interesting to reflect that back then it was thought that the sort of changes we're seeing here wouldn't happen until the time of my grandchildren, or maybe sometime long after that. And yet it's happening now, and it's happening much faster than was thought possible.
Scientists working here say that the rapid changes on the peninsula are being driven by human activity. But they haven't drawn any definite conclusions about Pine Island for one very simple reason. They just don't think they've observed enough. Yet.
Although we have seen some fairly dramatic changes, they're only for a very short time period. So really they've only been monitoring what's been going on since the satellite era, so since the late 1970s. And in terms of a time period to understand what's really changing, 30 years is very difficult to get any kind of statistical significance.
The next step is to look at ice drilled from deep down in the ice sheet in the hope that it will unlock the past.
Ice cores are an absolutely fantastic resource because they contain an archive of past climate. The most important and sort of most interesting ones, I think, is a record of past temperatures.
Liz Thomas has spent the season drilling ice cores at the edge of the West Antarctic ice sheet.
What we're interested in finding out is how the climate of the West Antarctica has been changing over the last 200 years. Okay, here she goes. Obviously we're interested in the causes of whatever is happening. Is this part of a natural cycle, so the climate has been changing many times over the past million years? So is this part of that natural change, or is this something that's a more recent effect, so something possibly anthropogenic, so human-induced warming or human-induced change?
Everyone I've spoken to about Pine Island has said the same. At the moment, they have more questions than answers. But there's one thing about which they're all in agreement.
I would say it is one of the biggest questions facing science. Not only science, but society, because there is potential for the changes we see to affect all of us.
Regardless of the cause of any of these changes, it's actually something, if you're indicating that it's increasing sea level rise, it's going to be something that affects everybody.
It does concern me. Yes, people have said to me, well, these things have happened in the past. That is absolutely true, and the sea level has been higher than it is at the moment. But back then, the humans that were around were very few in number, and they were nomads. They could move away from a rising sea level. Now we've got 7 billion people on the planet.
That's a thought echoed by everyone who works down here, and it's made me think about things in a very different way.
So, consider this. In a way, it really doesn't matter whether you think all the changes here in Antarctica are some sort of natural phenomenon or man-made global warming. The fact is they're happening, and with potentially disastrous consequences for all of us. Nobody knows exactly what the future holds, but it seems increasingly likely that the answer lies here in the ice.